Hey, fifth graders. We are going to go over some multiplying fractions review. So if you remember before we had our school cancellation, we were about to take a multiplying fractions quiz. So I wanted to go over all of the different topics you might see on this short, I believe it's a 10-question quiz, just to make sure we're all feeling good with it after we've maybe not been thinking a ton about math over the past couple weeks. So let's jump right in and kind of refresh our memories. So let's talk about estimating fractions so that we can apply that to estimating products. So the sizes of your fractions that you're multiplying matter, and it is going to impact the product of your problem. And remember, products are the answers to multiplication problems. So a fraction is approximately 0 when the numerator is close to 0 itself. So 1/5, 2/20. I could do something like 3/25 because 3 is very close to 0 out of 25 total pieces. So you barely have none at all. A fraction is approximately half when the numerator is about half of the denominator. So 5/8 is slightly more than half because half would have been 4/8, and that's really close. 4/10 is really close to half because 5/10 would be equal to half. And then you can choose an example for yourself. So I'm going to go with, 16/30 is close to half because 15/30 is equal to half. And a fraction is approximately one whole thing when the numerator is almost equal to the denominator. So for example, 9/10, 6/7, and 19/20 are really good examples of fractions that are almost a whole thing. If you had $10 and I took 9 of your dollars, you'd say, hey, you almost took all my money. So I almost took your entire amount. So how can we use this when we're multiplying fractions? Well, we can use this to estimate the sizes of products. So again, we can estimate the size of the product or the answer to a multiplication problem by analyzing the size of the fraction in the multiplication problem. Recall, when multiplying a fraction by a whole number, you are taking part of the whole number. And remember, of means to multiply. So for instance, if I have you complete the problem 4/5 times 20, really what that means is I'm taking 4/5 of 20. And now let's think about let's estimate what this product would be. Well, we know that 4/5 is really close to one whole thing. So we're taking almost all of the 20. So we are taking most of the 20. So I would estimate this to maybe be like, 19 or 18 or 17 maybe, because those are all most of 20. So I'm not going to solve it. This is just simply estimating and giving ourselves a ballpark. Let's do another example. So if I'm taking 1/10 of 50, I'm multiplying 1/10 by 50. Again, because of means to multiply, and since 1/10 is pretty much 0, it's really close to 0, you're barely taking none of 50. So I'm thinking like 1/10 of 50, that could be approximately like, 2 or 3 or 4 or 5. So it's a very small portion of 50. If I took 2 of your $50, I didn't take much at all. And the last example here, we're going to find 3/8 times 16, and that is the same thing as taking 3/8 of 16. Since 3/8 is really close to half, in fact, it's slightly less than half. We're taking about half of 16, and more specifically, slightly less than 16. So I'm thinking slightly less than half. Well, I know half of 16 is 8. So I'm thinking maybe my answer might be 6 or 7, maybe. And remember, those squiggly lines are your estimation symbol. So that's just kind of estimating the size of our fractions. Let's go ahead and move on and start model how we multiply these fractions. So we'll start with multiplying fractions by whole numbers. And remember, when multiplying a fraction by a whole number, you are creating multiple sets of that fraction. So if I'm for example, multiplying 4 by a third, this means you're creating 4 sets of a third, or in other words, 4 copies of a third. So as you can see here, I created, here's 1 set of a third, 2 sets, 3 sets, 4 sets. How many thirds are shaded in total? 1, 2, 3, 4 thirds are shaded in total. So 4 times a third is equal to 4 thirds, which is equal to, let's turn this into a mixed number. 3 goes into 4 one whole time, and there is 1 left over, so 1 1/3. Let's do another example together. 3 times 3/4 means we are going to create 3 sets of 3/4, or 3 copies of 3/4. So here's 1, 2, that's 3/4, that's my first set. 1, 2, 3, that's my second set. 1, 2, 3, and that's my third set. So in total, how many quarters did we shade in all? 3, 6, we've shaded in 9 quarters in all. And remember, these are indeed still quarters because I didn't change the size of my fractions at all. I'm still dealing with quarters. So 3 times 3/4 is equal to 9 quarters. And let's turn that into a mixed number. 4 goes into 9 2 whole times. That gets you to 8. And the difference between 9 and 8 is 1. So 2 1/4 would be our final answer. And let's go ahead and write out what multiplication problem is modeled below, because I might give you pictures and ask you to tell me what multiplication problem is being displayed. So here I have 5 copies of the fraction 1, 2, 3, 4, 5, 2/5. I have 5 copies of 2/5. Sorry, let me slide that up a little bit. So that is the problem, 5 times 2/5, and that gives us a grand total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10/5. And 10/5, let's turn that into a mixed number. 5 goes into 10 2 whole times with nothing left over, so your final answer would be 2. And what's interesting is if you take all of these little pieces, if we were to shift them over to fill in as many as we can, we would fill up 2 whole rectangles. I'm going to go ahead and pause this video because when my videos get long, it's hard to upload. So this is going to be part 1, and I will continue with the rest of it on the next video.